this by making the point that when you're doing a trig identity, or you're actually proving a trig identity, and you want to prove that the left side equals the right side, and the agreement is that you pick a side and you work on that side and you don't change the other side. So you usually start with the more complicated side and transform it to make it look like the other side. Okay, so work on one side at a time, not both. Here's the basic 8 trig identities that you're going to be using for these problems. And by the way, here's proof on Desmos that the left side is equal to the right side, because if you graph both of these, you get the same curve, which is really just the cosine of x. So let's punt by changing secant to 1 over cosine, which is from identity 2. Some teachers make you provide a reason for why you go from here to here. We won't do that here. Tangent of x can be replaced by sine over cosine, and there's the sine. If we simplify this fraction, we get sine squared over cosine. And now we have a common denominator. So 1 minus sine squared is the numerator. Cosine of x is the common denominator. And then here's the key. This is an alternate form of identity 6. Sine squared plus cosine squared is always equal to 1. You can subtract sine squared from both sides and get 1 minus sine squared equals cosine squared. So that's how I got from here to here. And then using algebraic simplification, cosine squared divided by cosine is cosine, but cosine is 1 over secant. That's an alternate form for this guy right here. And this is how you end a proof. Quod erat demonstratum. That which was to be proved, we're done. Some teachers suggest putting a smiley face, but some indicator that you have proved what you set out to do. And real quickly, we'll go over these other two. Here's the original identity. I'll choose to work on the right side because I've got to introduce fractions to make it look like the left side. So cosecant is 1 over sine, cotangent is cosine over sine. You've got two fractions now with the common denominator, so you can add the numerators. And now the right side looks like the left side, QED. And finally, number 3, here's the original identity. And you can see down here from Desmos, always equal to 1. So again, I would punt, which means change everything to sines and cosines. Obviously, the left side is much more complicated than the right side, so I'll work there. Replace secant with 1 over cosine, tangent with sine over cosine. Whoops, should be cotangent here. Cotangent with cosine over sine, and now algebraic simplification. 1 over cosine squared minus sine squared over cosine squared, multiplying in this term the numerator by the reciprocal of the denominator. And now we got a common denominator, 1 minus sine squared. It's the new numerator. We can replace that with an alternate form for the Pythagorean identity. And cosine squared over cosine squared, always 1. There you go. Hope that helped. If you have any questions, post a comment.